BMC designed its latest bike, the Teammachine R, with the help of the Red Bull Advanced Technologies crew. We're here in Austin on the F1 circuit, the Circuit of the Americas, outside the Red Bull paddock, where we can't take the camera, but we can take the bikes out on the track here. We're talking to both the Red Bull team and the BMC crew about how this bike came together, tell you a bit about that story, and tell you a bit about how this bike rides. My camera got run over. Was it by foot, bicycle, or one of these big boys? I'll have to go back and look at the footage to find out.
This camera's here.
BMC's latest bike is lighter, stiffer, faster. Of course it is, right? That type of talk is to be expected. What was unexpected for me was that BMC insisted that this bike is not an aero bike. It's an all-around road race bike. In my mind, however, it's an aero bike. It's a race bike, but it's an aero bike. What else do you call a bike with 62mm deep wheels and such deep aero shaping? In any event, I'll give you some numbers and some claims from BMC, share my ride impressions on the bike, share a conversation I had with Rob Gray, the technical director of Red Bull Advanced Technologies, whose team worked on the design of this bike. And then lastly, we'll talk comparisons to other aero bikes on the market, because of course we're going to compare this bike to other aero bikes. Weighing in the black and white corner, the Teammachine R weighs a claimed 910 grams for the frame in size 54. Built up, that comes to 7 kilos or 15.4, again in that size 54. This puts it a touch heavier than its sister, the Teammachine SLR, the all-around race bike. In terms of aero drag, BMC claims this to be 1.9% faster than the Teammachine, the outgoing aero road bike that this new bike replaces. Compared to the SLR, BMC did two types of comparisons. One with just bike to bike in the wind tunnel at 0 degrees yaw, just head on, and then with bike and rider / mannequin. There, the differences were quite a bit larger. BMC claims the Teammachine R is 19% faster, just the bike head on versus the SLR. When you put a mannequin rider on there, the difference is 3.5%. The frame obviously has deep shaping. Even things like the water bottle cages are part of the aero design, and BMC says the bike is faster with bottles in the cages than without. Up front, the fork with its big bulldog stance, BMC is calling this its halo fork. The thinking was you could go one of two ways to smooth the air coming off the front wheel. Either tighten the fork up as close to the rim as possible or go wide. You can see which BMC chose here. Compared to the SLR, it's also stiffer, both in terms of torsional stiffness, which you may or may not be able to feel, and in terms of lateral rigidity, which you can feel. This is fairly par for the course with aero bikes compared to an all-around road bike. Lastly, another number, 36. As in, you can have any width handlebar you like so long as it's 36 centimeters wide at the hoods, and then it flares to 42. This is true across all sizes. This is the same dealio as BMC has on its top-end gravel race bike, the Caius. I rode that and I'll tell you a bit about that. But first, let's talk about the ride feel of this bike. In many ways, this feels like riding a time trial bike with slightly wider handlebars. Efficient machines are fun to ride, especially coming from an endurance bike, something more upright with wider bars and fatter tires. Getting on a out-and-out hard-nose race machine is a delight in the right circumstances. The faster you go on aero bikes, the easier it gets, right? Because as your speed ramps up, the greater the proportion of your total resistance is coming from the air. And the more you can smooth that out, the faster you go at the same amount of effort. How much a bike feels fast is always a difficult thing to test out, and sometimes having a very rigid ride can feel fast when in actuality you may or may not be going faster. I liken that to riding in a go-kart, right? Like if you're just a few inches off the ground and you're getting bounced around on very little suspension, it can feel like you're flying. Compare that to the feeling of sitting in a nice, expensive luxury car going at 3 times speed, where it might not feel that fast. So it turns out, perception and reality are not always one and the same. With bikes, that's always something that's fun to debate, right? How much we can feel, how much we're perceiving, and whether that's based in reality or not. In any event, my reality on this bike was twofold. First, riding the roads around Austin with some editors from other titles like Matt Phillips from Bicycling, Josh Ross from Cycling News, and Alvin Nordell from Velo, as well as Delaney Watkins from BMC. Some side gusts felt downright propulsive on these deep wheels. Tires are 26, which is a little on the narrow side in this day and age. BMC says these tires were spec'd because that is the fastest combo they tested in the wind tunnel. Same goes for that 36 bar. On some of the rougher, chopped up roads outside of Austin, the bike felt a little bit rough, as stiff, deep aero wheel bikes do with skinny tires. Here, the skinny bars are a conundrum of sorts. You know that narrow is aero, and this is a faster position, but when the road is rough and you're getting bounced around either by the road or the wind, having reduced triangulation can, again, this is a perception thing, can reduce your steering leverage. So it's one of these many instances in cycling where there are two things at balance. You can either pick one extreme or the other, or figure out where the middle ground is here. With the BMC Teammachine R, BMC has chosen it for you. 36 centimeter bars. The first time I saw these 36 bars on BMC's Kayas, the gravel bike, I thought this is madness, particularly for gravel where steering is a higher consideration and aerodynamics is of less consideration than when racing or riding fast on the road. However, rode that bike for a few months and actually kind of loved how the thing felt overall, and the skinny bars weren't as bad as I thought. Took the bike to a few places, including Belgian Waffle Ride, Utah. Ended up winning the 45 plus there on that bike. And the steering was okay. It would not be my first pick, just to be absolutely clear, but it didn't feel dangerous. It definitely felt different. It's still strange to me that on a bike that's $16,000, 15,000 euros, you don't get to select the cockpit width. I get saving money and reducing manufacturing costs on a mold, but the bicycle buyer is not saving money here. You can select the stem length though from 80 mil to 140 millimeter. Riding the bike out on the Austin roads, it was fun to go fast in a group. One regular naysayer question to aero bikes is like, you don't need that. Nobody needs that unless you're professional racing. What does need have to do with it? What's wrong with just fun for fun's sake? And with everything tucked internally, this thing was a quiet riot, going fast in the wind. Now getting the bike onto the track, the Circuit of the Americas there in Austin, the bike really came into its own there. The surface was much better than some of the chunked up, chewed up roads outside of Austin. Heading away from the start finish, there's a steep climb where you can appreciate the stiffness of the bottom bracket, and then up over the top, the low drag profile was gratifying on the descent. Now I waited until I was back here at home to film this video because Rob Gray, technical director at Red Bull Advanced Technology, was out with COVID the week of that Austin F1 race, where Red Bull Racing's Max Verstappen continued his dominance, winning by more than 10 seconds. So here I talked to Rob about what his team did to help build out the Teammachine R.
This bike is really the third bike that we've been involved in with BMC. So there was a sort of concept study we did to start with, which was Project Speed. And then we moved on to the Speed Machine bike, which was kind of the productionized version of that. And then we came out with this Teammachine R. Our involvement's kind of increased with each of those projects. The Speed Machine, we were very much just looking at the aerodynamics. And then this latest project, we've been on the aerodynamics and on the composite side. So what did we actually do? Well, to start with, there was a lot of KPI setting with BMC. So they very much set the targets that they wanted us to achieve. And it was a mix of targets from different bikes. So a mix of time trial bike, aerodynamics plus road bike, weights, and trying to then get one bike that did the best of everything. So we had KPIs for weight, for stiffness, for compliance, for aero, and for cost. And then it was up to us to try and find a good set of compromises that gave the best possible outcome for the bike. The two kind of key systems we're using are something called CFD, so computational fluid dynamics, and that's looking at how the airflow moves around the bike and the drag of the bike. It's effectively like a virtual wind tunnel on the computer.
Sure.
And then finite element analysis. So that's where we optimize the layup of the bike, and more fundamentally, before you get into the layout, just looking at the fundamental geometry and how strong and stiff the bike can be from its actual shape. So we modeled several of their previous bikes to understand how they worked, and then we went into doing a bit of a study of various parameters to understand what will have the biggest influence on each of the KPIs. So whether that be looking at the spacing of the fork legs and seeing how that affects the aero, and then also understanding the effect on stiffness, and then really kind of sort of sounding out the space that we're working within to then be able to come up with what we consider to be the optimum of all those optimum solution of all those parameters.
Now, is BMC giving you setting parameters like with the fork, for instance, of saying like, okay, you can't make it more than 3 meters wide, or is it for aesthetics we don't want there to be a duck bill and
so there was definitely BMC definitely had an input on the styling side of it. We're also conscious of the regulation side of it, so it needed to be legal. So and then some practical considerations as well. I mean, silly things like being able to get the bottle in to the cage, for example. So BMC brought an awful lot of those kind of requirements to us. Where I'm a cyclist myself, but not all of the team are. So it was really useful to have BMC on hand to explain those kind of things. So progressing then, so we explored the space, we understood how varying the different parameters would affect the performance of the bike, and then we got into actually optimizing the aerodynamic design. So I did a lot of work on different iterations of aerodynamics to get to the point that we got the drag to where we wanted it to be, so hitting the KPI on the drag. And once that's done, we're then very much handing over that design to the structural guys and also to the styling. The styling have a bit more of an input at that point, and the structural guys then have to try to make that shape work in reality. And their job is to hit the stiffness and compliance targets. And I say stiffness and compliance because some parts of the bike need to be super stiff. Other parts you want compliance in to give some sort of more forgiving ride characteristic. So optimize the laminate for the stiffness and the strength in theory, and then went into a process of translating that laminate into an actual manufactured product. And so at that point you're taking, if you imagine, so on the computer you can have an infinitely variable number of fibers across the whole of the frame, and then at some point you have to get slightly more realistic about that and turn it into something that people can actually make. So it got turned into a laminate that we thought was manufacturable, and then that was then between BMC, really for BMC to liaise with the manufacturer of the frame, the company, the subcontractor, to make some prototypes. Then once we get the prototypes in, BMC are then testing them for to validate the stiffness predictions we've made, and also to test the physical strength, and also to make sure that the translation of laminate from our computer system into the manufacturing world has actually gone in the right direction, and we're getting the laminate in the places we need. And that was pretty much the process we went through.
Great.
I think we finished off with the wind tunnel test to validate the aerodynamics.
Mm-hmm, mm-hmm. Yeah, thank you for walking me through that. That working with FEA and CFD is definitely something that many of the larger bike companies do. So how different is what your process was from like what a Trek or a Specialized or a Pinarello will do? Is it just a matter of like computing power? Just to maybe tee you up to brag on your team a bit without necessarily throwing other bike companies under the bus, but just like what's the difference there? Just for context, I remember I was at Specialized for a while when Specialized partnered with McLaren, and the way they put it forward was like, well, we could just get, we being McLaren, we could just get closer to the edge, like having like a
I suppose
tolerances. So what's the difference?
I suppose the experience of using different materials would be the first thing I'd say we benefited from, or we're able to benefit BMC from. And perhaps we're slightly more aggressive on the fibre choice than maybe they have been in the past. So I think we pushed on that front. I think in terms of CFD, we have a very sort of huge cluster of computers that's used to solve the CFD cases, so to get a really sort of high fidelity understanding of what the airflow is doing around the bike. So there's more detail goes into that model perhaps than others would use. I'm going to be honest, I don't have sat in front of me what size computing power Specialized or Trek are applying to their bike. So this is kind of my assumptions. And on the FEA side, I suppose similar experience from optimizing components on other vehicles that we've done in the past, which has been derived from the Formula One experience, and really knowing a lot about how to use the software, having the computing capacity to solve it, and to get through lots and lots of iterations very quickly. Because that's the key thing is, if you design a component, you can, if you're lucky, you get it through the stress analysis department the first time through. If you're unlucky, it takes a dozen times. Or depending on, I'm saying lucky and unlucky, perhaps that's not the best phrasing, but depending on how complex the component is and how challenging it is, depends on how many iterations you go through. But every iteration you go through, you take weight out of the product, so weight out of the frame. So I think being able to iterate quickly means that you get more iterations in a given time scale and you get a better product at the end as the end result. I think it's also worth mentioning, BMC have some great facilities themselves. We've certainly enjoyed going over to their Impact Lab. They've got some very similar equipment to what we're used to seeing in Formula One world, but at the same time, I'd say, obviously the Formula One car is a much more complex thing than the bike, and so we just have a bigger range of equipment.
So, Rob, I hope you got a bicycle out of this deal.
Not yet.
So how does this compare to other aero bikes and to other bikes designed with the help or at least the branding association of car companies? We've seen this multiple times in the past. Ferrari working with Colnago, Specialized working with McLaren, etc., etc. Once you get up into the highly refined air of these top-end superbikes, the differences are pretty small. It's not a linear curve of the more you spin, the bigger the difference is. Once you get to a certain point, the differences are quite small from one bike to the next. Take the example of the time machine being replaced, a 1.9% difference. Price-wise, these puppies ain't cheap. The top-end machine, 15,000 euros, $16,000. That's with SRAM, red, and a power meter. Some other models include Dura-Ace Di2 for $14,500 US, a SRAM Force option for $9,500, and an Ultegra Di2 for $9,200. So certainly setting a high mark on price. In terms of aesthetics, functionality, and spec, there are some differences here. The fork, for sure, unless we're looking at something like the Lotus track bike, this wide stance sticks out among aero bikes. Narrower bars, certainly not unique to BMC, but committing solely to one width across all sizes, that is unique to BMC. And then lastly, the positioning, how BMC is talking about this aero bike is not an aero bike. This is a funny thing. As bike brands and bike riders, we struggle to define what we want to do in terms of the performance of our favorite toys, right? Do we want them to be as light as possible and thus sacrificing some aerodynamic benefit? Or do we want them to be as aero as possible and thereby gaining a few grams? Really, we want it all, right? I want a comfortable bike that's also light and stiff for pedaling efficiency and super comfortable, but it seems bike brands will pull these apart. For a while I was at Specialized, where there was the Roubaix, the comfortable bike, the Tarmac, the all-around stiff, light race bike, and then the Venge was the aero bike. And they all sort of got pulled closer in together because we all want all those things in one bike. The Venge got tossed out, and now the Athos is the super light bike. The Tarmac is the race bike that has aero characteristics, and the Roubaix is still the most comfortable bike. See a similar thing going on with Trek, where the Domani is the comfortable bike, the Emonda is the ultralight bike, and then the Madone is the aero bike. Despite the claims that this bike is faster than the aero bike it replaces, BMC says this is not an aero bike. Okay, I'd love to hear your thoughts on this bike. I'd love to hear your thoughts on aero bikes in general. Sound off in the comments below and we will keep the conversation going. Thanks for watching, thanks for subscribing, and whether you want to go full aero or full lightness or somewhere in between, enjoy the ride.
No leaving the track to gain an advantage.